Class, welcome to a Monday, the last Monday, the last class of the year. This is so cool. I'll see you guys next year, a year older, a year wiser, maybe a year wiser to some. Okay. So let's see. You guys tell me, do you guys see a sine curve in front of you? There's a, okay. Okay, sounds good. I'm going to do this here. I'm going to get rid of my face on the screen. And because then it works a lot faster than trying to cram a whole bunch of video and audio here. So let's do this here. We made this, guys. We made the sine curve. We call it a sinusoidal curve, which means it just bops up and down, up and down. Okay, first time ever, we're able to model things that have repeating behavior, from phases of the moon to pistons going up and down in a car engine. I mean, literally everything. We are able to finally model stuff with that. That's just super cool like that. Next is just want to show you the auto version of it. Let me jump to a different screen here. Okay, this will be just a quick, since we already finished it up here. Anyways, just want to show you the screen to it. This is, talk to me here. Do you guys see a Desmos graph on here somewhere?
Yes.
Awesome. Okay, so we're gonna go and make this little sine curve the same way. I just wish on Desmos, I wish it moved this graph, because it's technically two different graphs. I wish it moved the circle graph off to the side completely and then do the sine curve, because those are two different graphs. We good? Just so you guys to see it. So here it is, the sine curve. Dun, da, da, da. And we start off at 0. And so notice as this guy goes up, the unit circle is just going to go around. And this little green graph here, it started off at 0, 0, right? 0 for the radian measurement, and then 0 for that. And so as you graph these here, best way to see it is when you get it to the pi over 2 right here. So this little green graph is graphing the height, and it's graphing it this way. And then this one's just kind of going around the unit circle forever and ever and ever. And so here it is, goes down to -1, goes up to 0. And then we said last time, this guy can keep on going. Is that right? We just keep on going, because the radian measurement keep on. This one goes to 4 pi, but that's fine. So there it is right here. It's still going around the unit circle, still going down. And I thought that's a cool little thing right there. Boom, there's our little graph. Awesome. Okay. With that, we got to let's do the cosine curve one last time. Let's see if we can do it a little faster so we don't spend all class period like we do with the sine curve here. And then we'll do the animated version of it as well. So jump back to this guy. And we're going to quickly make our little table for the cosine curve. And I'll pick on people again to calculate it here like we did last time. All right, and let me situate this way. Let me get my computer for writing purposes here. Okay, am I still there? Just real quick here.
Yeah, still where?
Don't look at Adrian, he's blind.
He is blind fool. We are here.
Okay, let's go with theta, and let's go with cosine theta, or x, whatever you like to call it. X or theta kind of almost mean the same thing at this point here, which is just whatever symbol you want to use here. But normally, since we want to go with, sorry guys, with pins, just messing with you guys that have pins, man. So I'm going to go x here, and then we're going to say y equals cosine x. That'll be the more official version. We good? And Georgia, do you have a crown on your head?
Yeah.
Is that part of the pajamas?
It's part of the fact that I own a crown and I want to wear it.
Okay, sounds good. I thought that was part of the pajama. That is just naturally wear a crown.
What a crown to that.
All right. Let's go with it here. And again, I'm going to have you guys pick. And if we can do the table really quick here, this is going to be 0. I'm going to go with pi over 6, pi over 4, pi over 3, pi divided by 2. Then we have ourselves next on the docket. I think it is 2 pi over 3. Then it's 3 pi over 4. 5 pi over 6, and then just pi at the end right over here. And that gets us to 180. And the graph just keeps on going. After that would be 7 pi over 6, 5 pi over 4. Let's see, 4 pi over 3. Yep. And then 3 pi over 2. 5 pi over 3. Let's see if that's right. Just want to make sure here. Yeah. 7 pi over 4. 11 pi over 6. And voila, 2 pi is where we end up with. Okay, sweet. Okay, as we did before, I'm going to go from right side of the class to the left side of the class. So Hayden, you got 0. Boom. So I need the exact answer. Then I need I need a tenth to the nearest tenth here. Amaya, you got pi over 6, and we're going to go in order. So Haley, pi over 4. Rylan, pi over 3. Georgia, pi over 2. Nicholas, 2 pi over 3. Grant, 3 pi over 4. Grace, 5 pi over 6. And Adrian, pi. And Zechariah, 7 pi over 6. So I think I got all those guys. Boom, 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 boom. Give you guys a minute to calculate it here. So give me exact answer. And if you have your book with you, the back cover of the book has a unit circle on it for the exact answer. Then also I need a approximate answer for graphing purposes. And you know, we probably should do tangent as well. We're going to do tangent. All right, and back to Hayden. Tell me when you're ready and go for it here. Cosine of 0 is 1. Awesome. Maya, cosine of pi over 6.
It's square root 3 over 2 or 0.
Cool, yeah. 8 point, sometimes it's 8.66, 8.7, somewhere in that range. Yep, perfect here. Haley, all yours for cosine of pi over 4. Square root of 2 over 2, I think I heard. Is that right? Yeah. An approximate value? Zero 0.7, 0.71, somewhere in that range. Perfect. Okay, boom. Rylan, cosine of pi over 3. Awesome. 1/2 is equal to 0.5. That's cool. Georgia with the crown.
I got 0.
0 it is. Dun, 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 dun. Okay. Nicholas, cosine of 2 pi over 3. Awesome. Cool. And then I think you guys could almost do it by patterns here, but Grant, all yours for 3 pi over 4?
Negative root 2 over 2 or 0.7. Negative 0.7.
Mm-hmm. Perfect. And Grace, 5 pi over 6? Awesome. Adrian for pi? And Zechariah for 7 pi over 6? Negative root 3 over 2 still, so 0.87. Okay, so I'm going to go with the pattern here. Negative 1/2. This has to be a 0. Now we're going to come up to the positive side. So positive 1/2, positive root 2 over 3, positive root 3, and should be back to 1. That's my little pattern. Think we all agree. That's 0. 1/2 is a 0.5. Let's see, 0.71. 0.87, and voila. Okay, did we make our chart? Okay, and I'm gonna have you guys just play with and learn the graph little structure here. So the graph structure, just because we're doing all of it, we're gonna go like this. Give yourself a little space here. This is 1, this is 2. Negative, nope, let's see, yeah, -1, -2. And we are going to go from 0 to pi. And what we're going to do, we're going to break it up into pi over 6 each time. This is 2 pi over 6, or just pi over 3. 3 pi over 6. 4 pi over 6, which is 3 pi over 2. Sorry, this will be a little while. Just start making it a little graph. This will become easier and faster. And so we're missing all the pi divided by 4 multipliers. So we'll add those in a little bit later here. That's pi. Then we got 7 pi over 6. 8 pi over 6, which is really 4 pi over 3. 9 pi over 6, which is 3 pi over 2. 10 pi over 6, which is 5 pi over 3. 11 pi over 6, and 12 pi over 6, which is 2 pi. I'll let you guys just give you a little bit of time to finish that off.
Mr. Montiel,
Yes.
could you please zoom in on the graph?
Oh, yeah. Sorry. Thank you so much. Now, let me go like this here, then I'll just move it this way.
Thank you.
Uh-huh. And give me just a second here. Give me just a second. Let's go. Can I do, ooh, can I go and move the rest of them? That's why it's working. Okay, let me do this way. Oh, sorry, I was moving them the wrong way. Okay, are we good there? So the rest of the spots. Okay, then can you guys put in the pi over 4s? So going back over here, crucial point here, because these are not, they're not like 1, 2, 3, 4, 5. Right, you gotta think about where the where the pi over 4 is going to be, it's going to be halfway through. So you're going to make another little piece right here, pi over 4, in between. Yeah, we're good there with the pi over 4 as we're getting used to these graphs. So it's couched between the pi over 6 and the pi over 3, and it's closer. So you got to think of, if we think of, let's see, if we think of degrees, there we go. This is going to be 30, right? This is going to be 45 degrees. This is going to be 60 degrees. So there's a space of 15 between those guys. All right, let's moving on here. So this is going to be pi over 4. This guy's going to be 2 pi over 4. So then this one right here is going to be a 3 pi over 4. We've got a 4 pi over 4 is the pi value. Then this would be a 5 pi over 4 right over here in between the 7 pi over 6 and the 4 pi over 3. This is 6 pi over 4 or 3 pi over 2. 7 pi over 4 goes right here. And then the 8 pi over 4 is really the 2 pi. Okay, you guys talk to me. Are we okay with just the way the graph is set? Okay, once we're doing that, can you guys now take the graph, the table that we made for cosine, and let's see if we can put this on. So going backwards here, we should, yeah, I should do tangent as well here. So let's go with that here. So we said that cosine of 0 is 1. I'm going to put it right over here. Boom. Cosine of pi over 6. And I'm going to have to flip back to the graph itself, the table itself, just real quickly here. It is the 8.7. Okay, I think I have the rest of it memorized. Let me make this a little bit bigger. There, I think that's about as high as I can extend it out here. All right, let's go with it here. So pi over 6 is 0.87. That's a half. So I'm thinking like right over here somewhere. Maybe a little bit higher right there. This is 0.7. So a little less than halfway from 0.5 to 1, because the halfway point would be 0.75. At pi over 3, it is exactly 1/2. And then voila, it hits my little 0 right there. All right, and then the game is on. If you guys can finish it before me. Georgia, are you already done? Picking at Georgia today.
I started before you started explaining it. but-
Okay, gotcha. I was gonna give you a crown for it, but never mind.
I would like as many as possible. Really have
Okay, I'm gonna go with a let's see, a negative 1/2 now. Let's see, a point or negative 0.7, negative 0.87, and then a negative 1. Again, coming back, negative 0.87, negative 0.7, negative 1/2, 0, 1/2, 0.7, 0.87, and 1 is what we finish. Boom. Are we okay there? Does that look about right? Whoosh. Okay, and we connect them with just curves. Don't make it jagged either, because this is just a nice smooth curve. It should turn back over here, and then voila, end up with the 1. Okay. All right, the little nickname that we have given to cosine is just valley. That's what it is. Notice it's a valley. It starts off high, right? Then it goes down low into a valley and then comes back up. The nickname for sine is just hill valley, because we just do 2 of them. Cosine is just a big valley. Okay, it keeps on going. Yes, it does. Okay, and then let's go with our little let's see if I can find on this side here. I'm going to go to the slide here. I'm going to go to our little functions that we, or descriptions that we've got for these guys here. So domain, this can be our first thing. Range. Remember we had something called amplitude. Amplitude. Then we had something called period. Then we have to figure out how to do the zeros. And is it even or odd? So there's our little descriptions for our trig functions here. All right, and you guys can start filling them out if you like, if you're comfortable enough to do those. And look at what we did for sine. All right, hopefully everybody wrote them down already here, so let's go with it here. Domain, so the question is there ever a break in the graph anywhere? I don't think so. So we can put from negative infinity to positive infinity. Another way to write it is just say all real numbers. There's kind of two ways we do it. Those are the two ways we normally write it. Writing it out by hand or just in symbols, interval notation. All right, the range, just like sine. The lowest point it goes is a -1. The highest is going to be a +1. Then thinking back to the graph, you're just looking at this right here. You're looking at the lowest point that the graph ever reaches is here, and we go up to the highest point is 1, and that's it. So this is interesting. Notice the cosine curve does the exact thing as sine. It just goes bopping up and down, right? It goes up and down, up and down. So normally and customarily, if we have something that starts at the high value of something, we normally model it with cosine. If we have something that starts off at a neutral level, like 0, then we usually model it with the sine curve. So notice the sine curve is like this right here. But essentially, if you move the graph horizontally, you could move the sine graph to start here. And so sometimes when I say model this, maybe the question should be, Mr. Najeev, do you want the sine curve or the cosine curve? Because they can model the exact same thing. Okay. So amplitude. Amplitude is half of max minus the min. So it's the halfway point and then how high it goes. Think of the ocean when it's calm, and then you have the tide that comes in. So it's just the height of the tide, height of the wave. So graph wise, going back over here, it's the middle of the graph here, and then just how high does it go? That little piece right there. Or it's the range divided by 2. So in this case, tell me, you guys okay with just 1? Going from the middle of the graph to the top is just 1. Okay, period. How long does it take for this guy to cycle back? We're going to say 2 pi. Because our graph right here, once it hits this little +1 again, it's going to go down, which models this all over again, right? There's your 2 pi. Sweet. Okay, zeros, they're the fun ones here. Now zeros are, now let's talk about this here. So first of all, let's start writing out the zeros, if this makes sense. At pi over 2, we have a 0. At 3 pi over 2, we have a 0. So if this graph were to keep on going, so the pi over 2, 3 pi over 2, what would you guys say? What's the next 0 that hits right here? And do you guys see a pattern of zeros?
Always when it's over 2.
Okay, that's cool. And there's kind of, so I'm thinking 5 pi over 2 is the next one. Is that right? Okay. So then, um, let's think about it just a little bit further here. Let's do this one. Let's see. What's the difference from here to this one right over here? How long of a difference is that? How much does it go from 2 pi, pi over 2 to 3 pi over 2?
Is it 1 pi?
It's 1 pi. I think you are right, Amaya. So if we go 3 pi over 2, subtract a pi over 2, we get a 2 pi over 2 or just pi. So the length from here to here is pi. Notice if we do that same thing again, if we go over here, we extended another pi, we're going to get 5 pi over 2. Are we good? So normally, what we do is we figure out where it happens first time. First time happens at pi over 2, and then we think of the interval that's needed to get to the next one. Because notice this is going to be 1 pi. To get to the next one, we just need a 2 pi, and we keep on going. It's kind of like our sine curve. Remember, let me jump back to the sine curve because we're going to be jumping around just a little bit here. Okay. Notice we did the same thing here with sine. It was x is equal to k pi, and then we had this little extra little piece here. K is an integer. That's kind of how we want to set it up. And so we go over here and we say to ourselves, okay, that's cool. First time, so now let's write the symbols for it here. First time it occurs is pi over 2. And then each time there's a difference of pi. So this is k pi. And then here we go again, where k is an integer. Okay, that's the way the book does it. That's the normal way of seeing it. You know what we should do is we should say just x equals. That's x equals all that. That's not the only way of writing it, because I could just say, here's the other way of writing it, and other trig books write it like this. Let's see if you guys agree. Tell me if you guys think it's the same thing. Other trig books write it like this. X is equal to k pi over 2, and we just say k is an odd integer. Is that saying the same exact thing? So odd integers, I think we see odd integers here, right? 1, that's an odd integer. 3, 5. So if I say k is an odd integer, it fits as well. Does that make sense? Cool. Okay. Cosine, even or odd? So if we were to go backwards here, does this symmetry about the y-axis or symmetry about the origin? That's symmetric about the y-axis. That's cool. So if you have symmetry about the y-axis, it kind of looks like this graph. The x squared graph, right? You can fold it on itself along the y-axis, and this graph will fold right on top of itself. We call this the even function. So cosine is an even function. Okay, talk to me. Are we good there? Does that make sense?
Yes.
Okay. This is fun little thing. Okay, let's do tangent, and then I'm going to give you the graphs to the other ones here, but let's do tangent kind of quickly here. Let's see, we have what, 10 minutes left? Yeah, I think we can do tangent and then all the rest of the graphs. And then the homework assignment for you guys will be actually, we'll see. Okay, let's jam. Let's do a table for tangent. So x is over here, and I have y is equal to tangent x. Now this one's a little tougher because remember, tangent is the ratio of sine over cosine. So we're going to have to spend just a little bit extra time on it here, but we should be able to still graph it here. So 0 pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4. On my slide, I think I'm going to have to do 3 rounds here, or 3 tables here. I could just keep on going. 5 pi over 6, pi, 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, let's see, 5 pi over 3. And that may be a little squished here, but we'll see here. 7 pi over 4. I'll do it like this. 11 pi over 6 and 2 pi. Dun, 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 11 pi over 6. There it is. Okay. So tangent. Tangent is the ratio of sine over cosine. So you have kind of one of two ways here. If you have a calculator in your hand, you can just press tangent and you're good to go. If you don't, if you're looking at a unit circle, you got to sort of see what sine is, cosine, and then divided by one over the other. Okay, so let's do this quickly then here. So same exact values here as you guys do them. So Hayden, you got 0, and then Amaya, pi over 6, Haley, pi over 4, Rylan, pi over 3, Georgia, pi over 2, Nicholas, 2 pi over 3, Grant, 3 pi over 4, Grace, 5 pi over 6, Adrian with pi, and Zechariah with 7 pi over 6. And we're going to try to do this in 5 minutes or less. So let's go with it. Hayden, all yours. What do you get? And then give me just the approximation. If you guys can just give me an approximation, that'd be good. Go ahead. 0. Dink. Amaya, pi over 6.
0.58.
Say again?
0.58.
5.8. Okay. Haley? Just 1. Yeah. Just 1. Rylan, pi over 3. And Amaya, if you hear, I think I can hear you easiest. So if
1.73.
Thank you so much. 1.73. There you go. Georgia?
My calculator does not want to do it. It's saying it's an error. So
That is so funny. Georgia gets an error. We might have to take away your crown.
yeah, it's just intimidated. I do too.
Okay, so let's see what's happening with tangent with pi over 2. Tangent pi over 2, what happens here is you get yourself a 1 for sine, but a 0 for cosine. And so you have yourself undefined. So the quick little way of writing undefined is just UND. All right. We're good there, Georgia. Nicholas, all yours. 2 pi over 3.
-1.
Okay, and I think we can start looking at just the patterns. Grant, all yours.
-1.
Thank you. Grace.
-0.58.
Adrian.
0.
Thank you. And Zachariah.
-0.
It should be a positive, huh? Because we're in quadrant 3 now.
0.58, he said.
Okay. Like that, 0.58?
Yes.
Awesome. Okay, I'm going to continue the patterns here. So 1, 1.73. That should give you, oh, this is another undefined. And then we got ourselves a 1.73, a 1. Oh, sorry, negative here, right? Negative, negative. In quadrant 4, a negative 0.58, and then back up to 0. Okay, graph-wise, with 2.5 minutes left, what does this look like? All right, and then let's do the graph here. I'm going to zoom in on it here. Okay, and this should be very, very familiar to you now. So pi over 6. And let's see, I wonder if I can get this little middle now. This is going to be pi over 4, pi over 3. That gets over there. And then we skip a line, or we go to the next line completely here. This is 3 pi, 2 pi over 3. 2 pi over 3. 3 pi over 4 with a 5 pi over 6. Then we hit pi. So see if we can do this all in order. This would be 7 pi over 6. 5 pi over 4. 4 pi over 3. Then we get ourselves a 3 pi over 2. And then 5 pi over 3. 7 pi over 4 and 11 pi over 6. Okay, with a minute to go, here's the tangent curve. Here it is. Tangent goes 0, 0, as we said. Then it hits to a 0.58. So let's see, this is 1 here and 2 here. So this is 0.5. 0.58 is going to be just a little bit here. Okay, at pi over 4, it hits 1. Whoa, and at pi over 3, it actually hits 1.7. So it's actually all the way up here. And then what we have to do, since we got undefined, you guys remember from algebra 1 or algebra 2, whenever we got undefined, it was an asymptote. We drew these little dashed lines coming straight down. Like, you know, because there's a break in our graph right here. Okay, and we're running out of time. So we're going to go, next one is going to be here, be a negative 1.73. This would be a negative 1, negative 5.8, 0. And then it repeats itself. So there it is, there it is, there it is. And then there's this little break again on my graph. And then it starts all over again. So negative 1.7, negative 1, negative 0.58, and 0. So because of these little dashed lines, what we have to do is we curve up like this, and then we put an arrow. And then over here, sine's going to come in like this, or tangent's going to come in like this, has this little curve like this, and then it goes up again. And then it hits 0. Okay. We have not got through 4.1, but we got our tangent curve. And so we'll continue with that after break. And you guys can't ever tell me that I never gave you guys something, because I gave you a cosine curve and a tangent curve today. Okay, you guys enjoy your break, and we'll finish up the rest of them in January, and we'll keep on going. So see you guys in a while. See you guys in a year, or at least into next year.
Oh, wait, now I know what you're talking about, yes.
Thank you, Amaya, so much for doing the chairs there.
No problem.
Who will remember?
We totally forgot last time, I think. Yeah.
Thanks, Amanda.
Oh, thank you, Jenny, so much. Yep. Okay, so let me
Okay.
get out of here.
Passing the men and